Scale Drawings Lesson 7. So today we're going to be exploring some scale drawings. Today's ICANS, I can explain what a scale drawing is, and I can explain what its scale means. I can use a scale drawing and its scale to find actual distances. I can use actual distances and a scale to find scaled distances. So today's date, your ICANS, page number, and you're ready to move on. All right, so we're going to do a little warm-up here of what is a scale drawing. Have you seen any scale drawings? Some examples? You've probably seen some examples, things like maps. Obviously, we don't have a map of the school that's as large as the entire school. It's a scaled copy, so that way you can find your way around, but it doesn't necessarily have an exact 1-to-1 ratio of the size of the building to the size of the map. Over here on the left, we've got scale drawings of a bus, a quarter, and a subway, lines around Boston, Massachusetts. Over here on this other side, we have 3 drawings that are not scaled. How do we know the difference? In other words, why are these ones on the left scaled and these ones on the right not scaled? Well, some things to think about while we're talking about this here is our scaled copies look like, in the case of the bus, this looks like the exact dimensions of the bus, whereas the not scaled copy is generally the shape and outline of a bus. However, it's not the same as the bus. Quarter, if we're talking about a scale drawing, we have another drawing here of a quarter. And while it does have the general shape and the general parts, it is not everything in the same scale. And same with these other ones. This map is a scale drawing of a bus, of bus lines in Boston, but this other one is not a scale drawing of bus lines because look, we've got straight lines. No city has completely straight lines for a bus to go around in. So that is not what's going on here. You can see some of the aspects that are similar to what's going on, but in the scale drawing, we have a realistic depiction of the actual thing. In the not scale drawings, we do have a depiction of those things that we can clearly see that they are represent those things in some way, but they don't have all of the same things. And a scale drawing will have all of the same parts, just smaller or larger depending on the scale factor. Let's talk about sizing up a basketball court. So, do you think you could throw a basketball across the width of a basketball court? What about throwing it the full length of the basketball court? Well, I would think most of you could throw it across the width because the width is not as long as the length. And there's probably a good chunk of you that could throw it the entire length, but not necessarily everybody. Thinking about a basketball court, if you're going to do a scale drawing of it, let's say that 1 centimeter for every 2 meters is what it looks like they're using for a rate here, right? Because we have the scale drawing, the length of the court, 16 2/10 centimeters on a piece of paper, and the actual court is 32 4/10 meters. Well, that is twice as much, and it is using meters, which makes more sense for the length of a court than centimeters. And centimeters would make sense if we were making a scale copy of it. And the same thing with all of these numbers across. So first thing I want you to think about is, does 1 centimeter for every 2 meters mean the actual distance is twice that on the drawing? Well, you can kind of think of it two ways, right? You could say yes, because if you look just at the numbers, we've got 16 and 2 tenths, and if you double that, that gets you the 32 and 4 tenths. What makes that a little bit tricky is that it's the actual distance is twice what the drawing is. Well, the drawing is in centimeters. Is a centimeter and a meter the same? No. 2 here says, which parts of the court should be drawn using this scale of 1 centimeter for every 2 meters rule? Well, I think the major ones are going to be the length of the court and the width of the court. The hoops could be drawn, but it doesn't say the distance of those hoops across. So really, it's only these two major ones. Could make an argument about the 3-point line from the sideline, but that only gives you from the sideline in just a little bit. It doesn't give you the total arc that makes the 3-point line. Can we reverse the order of in which we scaled the actual distances? Like, could we say 2 meters of actual distance is 1 centimeter on the drawing? Or 2 meters to 1 centimeter? You can, again, it's about making sure that the person that you're talking to is understanding what you're talking about, and that you're giving enough information for them to understand. So while you could use those other methods, it's more about making sure that you're communicating what your scale factor is doing and how it's working. All right, let's look at some really tall structures around the world. So we have a listing of some of these giant places. The Great Pyramid of Giza. We can see how it scales compared to those that are around it. Eiffel Tower comparatively. Willis Tower in Chicago. The CN Tower in Toronto, Canada. And the Burj Khalifa that we talked about earlier in Dubai. So here we have a comparison of all of those places in the world. What does this represent here? Well, this is giving you an idea of scale, right? So this distance represents 100 meters. Now, for the Great Pyramid, we can see that that is slightly over 100 meters. It's not quite what would be 200 meters, right? Probably 150 meters. We can see that the Eiffel Tower is just about double that height, right? But then as you get into more modern buildings, you can see that 100 meters really jumps fast as far as being a very small piece to help us. So this gives us an idea of the scale for all of these. And we can clearly see that the Burj Khalifa is much taller than any of these structures. In fact, you can almost stack a couple of the structures together and still not be quite tall enough. I mean, if you took the CN Tower and put it on top of the Eiffel Tower, you'd probably get almost close. That just tells you how large or how tall it really is. So I talked about that using this helps me realize that the Great Pyramid is probably somewhere around 150 meters, because we can look that it would be right around here. And let me get my drawing tool. And if I'm going to here, and my distance is this much, that's roughly 200 meters, we can see that the Great Pyramid comes pretty close to the middle. I mean, you can make your argument of being 125 meters or something like that. What about the Willis Tower? Yeah, it's going to be significantly taller than that, right? So you probably have, what, 500 meters, maybe more? And Burj Khalifa is much higher than that. CN Tower, you can see, is pretty similar. You're talking just a few meters difference here, because if you look and you bring this pretty close straight over, you can see that it's not a significant difference as far as the height, but it is definitely taller. On the scale, it doesn't look as much, but when you also think about how this is 100 meters in this tiny space, when you look at the real thing, it's pretty big. So besides the height information, what else could we determine from that? Well, we could talk about, how they compared as far as the main building part and any antennas or whatever that are on top of the building. We clearly don't know the exact size, right? And how is this scale drawing that we were just looking at similar to what we did with the basketball court? Yeah, they have some sort of distance. This is roughly a centimeter is equal to 100 meters. But even if it wasn't, the fact that we have some sort of unit of distance representing on a drawing what in real life is significantly larger. All right, so the tallest mountain in the United States is Mount Denali in Alaska, and it's about 6,190 meters tall. If this mountain were shown in the scale drawing, how would its height compare to the other structures? Well, if it's 6,190, that is back here, that is 62 of these going up. So it would not fit on this picture, would it? It would be significantly larger. You would just see a part of it, just the tiniest piece, because even if we went all the way up with the Burj Khalifa, that you're still significantly farther than 6,100. That would be 61 times this distance, which is clearly well off the screen and off the scale of what we have there. We would have to, it would just make everything else look tiny. It would make what the Burj Khalifa makes the Great Pyramid, it would look like nothing. This giant difference that we see here, it would be way more than that, and that would be compared to the Burj Khalifa. Let alone to the size of the Great Pyramid, that'd be like a person standing next to the Great Pyramid. It's just a very significantly different height and scale of what it is. So what is a scale drawing? A scale drawing is a scale representation of an object. How do we describe the scale for a scale drawing? Scale tells us how the lengths of the drawing relate to the lengths of the actual object. Again, it kind of goes back to ratio. And how do we find the distance using a scale drawing? We can use a scale to find the lengths of the actual object by using that scale. So like we talked about before, if you're talking about 1 centimeter is equal to 2 meters, we know that if something is, let's say, for example, 5 centimeters drawn, that in real life, it would be 10 meters long when you drew it out. Okay. All right. And we are set for today. Thanks for watching.